Hi everyone. So today and my team, David, Jacqueline, and Tron, will present you the program that we work on, the N-Queen problem, solving by genetic algorithm. So first of all, I will go to the basic structure of our program. So we break down the project into two parts: the back end and the front end. So the back end basically handle on the function and the functional flow that we build up on a genetic algorithm. So the first of all, we go through genetic search, which is basically initialize on the instant that the problem needs, the mutation rate, the generation number, the n number, and then like passing all these parameters into the main function called genetic algorithm. So the genetic algorithm do on the task that we basically go through the lecture slides before the professor mentioned. There is a breadth, which is initialize population size, and we select some population from that, and we cross over, and then finally we mutate one spot in that result chromosome. So these thing, these action actually live until the program find the fittest individual with the fitness value equal the n multiplied by n minus 1 and divided by 2, because that's all the pair of queen that non-attack each other. And to do this thing, we must have the subparity library, which is on the subparity function inside the church and the utility files. So from the front end, we'll use all these back end function to, first of all, we are setting up background file and the game screen, which is reuse all the code that implemented already inside the back end. So in this game screen, we have some function like pick and choose and mutation rate, generation, and n value. And also we allow the users to cancel or restart the game at any time. And the next thing is the actual program demo, which I'm pleasure to introduce my partner. David will continue my part. Thank you.
Hi everyone, my name is David and I'm going to be showing you the program demo. Our program uses PyGame to render both a menu and a puzzle scene to the screen, as well as properly respond to user input. As you can see, the first scene here is the menu scene, and by clicking on start, it's going to take us to the main puzzle scene. In the puzzle scene, changes to big N's value will actually adjust the board by increasing or decreasing the size. Big N has a minimum value of 4 and a maximum value of 10. Once the user inputs the correct big N, NGen, and mutation values, pressing find solution will actually have our program start searching for a solution. While searching for a solution, the current iteration is printed to the screen, as well as a cancel button for the user to cancel the search at any time. As soon as a solution is found, the string is printed to the screen, along with the total iterations it took to find the solution. A graphical representation is also printed just above on the actual chessboard. The user's only option at this point as far as navigation is just pressing return to main menu. Just to show an example of a different size big N value, we'll choose 6 and then go ahead and press find solution. Then lastly, we'll demonstrate pressing the cancel button, which will take you back to the main menu in the middle of a search. Next, Jacqueline's going to talk to you about some contributions we'd like to add in the future.
In conclusion, the genetic algorithm helped discover biological concepts and solutions for the N-Queen's problem. For future projects, we can use genetic search and the genetic algorithm in back-end developing to improve performance through select various mutation values and multiple crossover functions. For front end, we can provide a running interface per step and implement other solutions using the same genetic algorithm and game concept.